So this is Trigonometry 3, which is a Form 4 topic in the KCSE syllabus. And earlier you had learned about the trigonometric ratios, that is trig ratios. This consists of the sine, cosine, and tangent. So these three, you had covered it earlier. And you know that the sine for a right angle triangle, sine theta is equals to opposite side divided by the hypotenuse. You know cosine is equals to adjacent side over the hypotenuse, and you know tan is equals to tan theta, that is, this is theta, is equals to opposite over adjacent. So here we have a triangle. This is our y-axis and this is our x-axis. So we call this a starting point. So this is the angle theta, and this angle here is 90. So this is the side that, okay, let's label this to be, this is A and this is B. So this is our opposite side, and this is our adjacent side, adjacent to the angle, opposite to the angle, and this is the hypotenuse. Let's call it H. Now in this lesson, we are going to deduce what we call an identity, which we are going to derive from this triangle that is in trig ratios, and we are going to say that the sine of an angle, sine theta, is equals to opposite, let's call this AB, divided by the hypotenuse, which we can write as we cross multiply that AB is equals to H sine theta. Then we have cosine of theta is equals to, it is adjacent, so we can say it is OA divided by the hypotenuse, which we can say that OA is equals to H, the cosine of theta. That is when you cross multiply. Now, having come up with that, then we know that the Pythagoras theorem says that the square of these two sides, the sum of the square of the small sides is equals to the square of the wrong side. So that is what we call the Pythagoras theorem. So let us see how that Pythagoras theorem is going to help us come up with the identity that we want to derive. Now, the Pythagoras theorem, so we apply the Pythagoras theorem. That is Pythagoras theorem. Since this is a right angle triangle, we say that OB squared is equals to OA squared plus AB squared. But remember, we have defined our AB and OA. So we can say, and our OB is H, so we can replace this H squared is equals to, our AB is equals to H sine theta. So this is H sine theta, and we square that, plus our OA is H cos theta. This is our OA, so it is H cos theta, and we square that. We open the bracket to have our H squared is equals to H squared sine squared theta plus H squared cos squared theta, we can divide throughout by h squared. So we have h squared, we have h squared, we have h squared. So h squared and h squares will disappear, so that will go with that. H squared will cancel with that, h squared will cancel with that, and we will be left with now we have sine squared theta plus cos squared theta, that is this side and that, is equals to 1. So this is called trigonometric identity, and it is true for all, that is, it is true for all theta. We also know that tan theta, we had covered that area, is the same as sine theta divided by cos theta. So that is the identity that we wanted to derive, which we are going to use to solve some trigonometric relations by use of that. So let's do a few examples, and we'll be able to see how we apply this trigonometric identity. Our example 1 says if tan theta is equals to a, show that cos theta sine squared theta plus cos cubed theta, they are all divided by sine theta, is equals to 1 over a. So for you to be able to do this, we are going to apply the identity, trigonometric identity that we have run, and it is important to know that we want to simplify this as much as possible, so that we end up with an equivalent expression of the other side. So we normally call this our left hand side, and this is our right hand side. So what we want to do is to simplify the left hand side, so that it is equals to, or we can prove that it is equals to the right hand side. Again, it is important to note that it is easier for you to simplify the left hand side to get to the right hand side, rather than expanding the right hand side to get to the left hand side. So you always check which side is easier to simplify. So we are going to simplify the left hand side. So here we have cosine theta, and here we have cosine cubed. So we can factor out cos theta. So here will be left the left hand side. Inside the bracket we have sine squared theta, then plus, because we have factored one cos there, we will be left with cos squared theta. All this is divided by sine theta, which is equals to, now instead of writing 1 over a, we write it is equals to left hand side. We have learned that in our previous part, that sine squared theta plus cos squared theta is equals to 1. So that is our identity. So if you check here, you find that then we can equate this to 1. So this means that if this is equals to 1, it is cos theta multiplied by 1 remains the same, divided by sine theta is equals to the right hand side. The right hand side. Now with that, we can say that since we know that tan theta is equals to sine theta over cos theta, it means this simply means that 1 over tan theta is equals to 1 over Sine theta over cos theta, which it is the same as 1 divided by sine theta over cos theta. So it means 1 over tan theta is equals to cos theta divided by sine theta. Now with that, it means that now what we have here is this means that this is equals to 1 over, since we have found it is equals to that, 1 over tan theta is equals to the right hand side. And because we had been told that theta is equals to a, so it means this is the same as 1 over a, then this means that the left hand side is equivalent to the right hand side, and that is how we prove that is 1 over tan theta is the same as 1 over a is equals to right hand side. But the right hand side is 1 over a, so we have proved that the right hand side is equals to the left hand side, and that is how you work out and that is how we apply the trigonometric identity. So this is our second example, and it says that show that 1 minus cos theta into bracket multiplied by 1 plus cos theta into bracket divided by 1 minus sin theta into bracket 1 plus sin theta is equals tan squared theta. So like I said, I've said in the last example, we refer to this as the left hand side and this is the right hand side. Then we check the both sides. Which side can we be able to simplify to end up to the other? So you find that this side is easier to simplify to get tan squared theta rather than expanding tan squared theta to get the right hand side. So we'll do that by expanding our factors here. So we multiply 1 times 1 and that will give us 1. Then 1 times cos theta, it will be plus cos theta. Then minus cos theta times 1, you get minus cos theta. This is cos. Then we have cos theta minus cos theta plus cos theta. You get minus cos squared theta. We do the same to the numerator. 1 times 1, you get 1. 1 times sin theta, you get plus sin theta. Then 1 minus sin theta times 1, you get minus sin theta. Then minus sin theta times sin theta, you get minus sin squared theta is equals to the right hand side. Now, with this, we can say that cos theta minus cos theta goes, and sin theta minus sin theta goes. So in the numerator, we will be left with 1 minus cos squared theta, and the denominator you will be left with 1 minus sin squared theta is equals to the right hand side. Now we have learned about the identity, which we have said that sin squared theta plus cos squared theta is equals to 1. So this means that if you take a cosine to the other side, it will change to minus. So you have sin squared theta is equals to 1 minus cos squared theta. Again, if we take cosine to sine to the other side, we will be left with the cosine. So we have cos squared theta is equals to 1 minus sine squared theta. So with this, we can now replace our expressions here. So 1 minus cos squared theta can be replaced with the sine squared theta. So the numerator will be sine squared theta divided by the numerator 1 minus sine squared theta can be replaced with the cos squared theta, this one. So you say this is cos squared theta is equals to the right hand side. So we know that tan theta is equals to sine theta over cos theta. So if we square this one, so it means we have sine theta over cos theta, which is equals to sine squared theta divided by cos squared theta. This means that if we go back to our expression here, we can write the left hand side is the same as tan squared theta is equals to the right hand side. And we know from what we have been given, the right hand side is equals tan squared theta. So we have proved that the left hand side is equals to the right hand side using our identity, which we know it is sine squared plus cos squared theta is equals to 1. Our example 3 says, given that sine theta is equals to a third, find without using tables A cos squared theta, B tan squared theta. So for us to be able to do that, we can make a sketch. We know that sine theta is equals to opposite of a hypotenuse. So using a sketch of a right angle triangle, so if we say this is theta, then it means since sine theta is opposite of a hypotenuse, this side is 1 and this side is 3, so that sine theta is the opposite side over the hypotenuse. And therefore, we can get the adjacent side, that is this side, by use of the Pythagoras theorem. We say that, let's say this adjacent side. So adjacent side is equals to the square root of 3 squared minus 1 squared, which is equals to, this is the square root of 9 minus 1, which is equals to the square root of 8. So it means this side is square root of 8. Having obtained the adjacent side, then we can come up with the part A of the question. So A says that cos squared theta, which is equals, we can expand and say this is cos theta multiplied by cos theta, and from our sketch here, cos theta is equals to adjacent of hypotenuse. So it is root 8, which is the adjacent side, and this is our hypotenuse, divided by 3, you multiply by another cosine, root 8, divided by 3, and when you open the bracket, the root of 8 multiplied by the root of 8 will give you 8, divided by 3 times 3 is 9. So it means that cos squared theta is equals to 8 over 9. So that is true. So part B of the question, that is B, we are told to find tan squared theta, which we know it is equals to tan theta multiplied by tan theta, which is equals to tan theta here is opposite over that is opposite over adjacent. So they have opposite is 1, adjacent is root 8. You multiply by 1, another tan, the root of 8, which is equals to 1 divided by root 8 times root 8 is equals to 8. So tan squared theta is equals to 1 over 8. So that's how you work out that question without using tables or the calculator. This is our example 4, and we are told to prove the following identity. So cos theta tan theta divided by sin theta minus cos squared theta is equals to sin squared theta. So let's deal with this is our right hand side, this is our left hand side, this is our right hand side, and we write, okay, this one we can write cos theta divided by sin theta multiplied by tan theta can be written as sin theta. So instead of writing cos theta, we write sin theta divided by cos theta, which we know is the same, minus cos squared theta is equals to the right hand side, So this cos theta will cancel with cos theta, sin theta cancels with sin theta, and therefore we will be left with the 1 minus cos squared theta is equals to, this is theta is equals to the right hand side. So with this, from our identity, we know that the sine squared theta, when you take the cosine to the other side, it is equals to 1 minus cos squared theta. So we know that. Therefore, we can write our left hand side as sine squared theta is equal to the right hand side, which is what we have been given here, and therefore we have proved that the left hand side is equal to the right hand side. So it is not always that we equate the left hand side or we simplify the left hand side. Sometimes you find questions whereby you can simplify the right hand side, you equate to the left hand side, and therefore look for more questions which you can work on. Maybe you can consult with your maths teacher. So that brings us to the end of our lesson 1 in this topic. You can go ahead and watch lesson 2 up to lesson 4, and by the end of the lesson 4 you have covered the whole topic.